Hello guys and girls, Elias is here. In this episode, we will be building a full serverless application from end to end. I'll take you on a journey with me and I'll be sharing my browser, my command line, and my IDE where I write the code. We'll go through all the steps, the design, the infrastructure, and the implementation of the logic itself. So by the end of this episode, and if you have paid attention, you will be able to build a full stack end-to-end serverless application that uses Lambda functions, API gateway, DynamoDB table, step functions, and other components we will discover along the way. Let's do this. Now, this is my screen and I will be sharing it with you as we go. I go to Lucid Charts and I'd like to click on Ads. And let's create a blank document and we should get going. First thing I always add is the 2019 shape library for AWS. So I'm building a container that's going to contain my AWS components. Usually you'd want to start with a high-level model in Solutions, something like C4 models. But for the sake of this, I'm going to go directly to the infrastructure diagram, because what's most interesting to us is the components and how we can implement them into code. I'm going to split my application into a write app, let's call it a write app, and then a read app, right? One aspect of my application will do the writing, another one will do the reading. Both of them will write and read from one specific DynamoDB table. We're going to choose DynamoDB table. And if you're not familiar with DynamoDB, I will leave some links in the description to get yourself familiar with these. But my suggestion is to just type purpose-built databases on AWS. Go to the first link and then read a little bit about all these purpose-built databases, the relational database, key value, in-memory, and you'll see that the one that we use, DynamoDB, is a key value, or what we call, it's a NoSQL. Back in the day, we used to use MySQL or relational databases for everything. Now, don't be afraid to use multiple databases in your application. If you have some data that you will be using to build analytics, well, you know what? You can store it in a time series database, right? It's easy to slice and dice and get all that information that you need. If you have another type of data that better, if it's relational, then, use something like RDS, which supports multiple flavors, multiple engines like MySQL, Postgres, MariaDB, Oracle, and other stuff. We're all pretty much also familiar with in-memory databases. I'm sure you already use Redis or Memcache or something like that. So that's a different type of database. And they're graph databases. If what you're building is something similar to a social platform, you're pretty much traversing a tree and making decisions. So this user has bought these items, and these items have been bought by these other type of users. Well, these users, they live in this city and they buy these type of goods. So like once you have these, you're required to get these connections. A better database for it is something like Amazon Neptune, which is a graph database. There's also an open source one, log something like this, but Go managed. You don't have to go through the hassle of maintaining all these kind of things. So we go back to our table, our database. I'm just gonna call it, it's a DynamoDB table. It's not really a database in the relational type, in the relational term. All right, so now to read my application, let's go simple. First thing I'm gonna do is I'm going to have a Lambda function. Haha, no surprise there. I was going to go for a Lambda function. Reader. I'm just gonna call it reader. And my Lambda function goes directly and read from here. And in front of the Lambda function, in order to expose this Lambda function, I'm going to put an API gateway in front of it. There you go, an API gateway in front of it. So this is my gateway that will expose a URL, and when my customers load that URL, well, they will be loading my Lambda function that's gonna process that request and go to the database and fetch the information. Let's say we're just building a CRUD application here, right? Create, update, delete, create, read, update, and delete application. Nothing super fancy. What do we want to put in front of the database? Probably we want to put some caching layer, right? And so DynamoDB has this thing called DAX, which is Amazon DynamoDB Accelerator. And if I type it here, it's pretty much a fully managed, highly available in-memory cache for Amazon DynamoDB that delivers up to 10 times performance. You could read a lot more about it, but what it is, think of it as if you put a Redis cache in front of your database, but you don't have to manage it yourself, right? Use as many managed services as you can. That's the way to go. Up. So this is our DAX. I'm going to put it here, and I'm actually going to be, it's not the fanciest diagram, but I will do. You know, let me just put it here.
2 hours later.
This is DAX. What else do you think should I put here? So requests are coming, logs. You know, I want to keep an eye on my logs. I want to know exactly when things are going wrong or whatever. So in AWS, what you want to use is CloudWatch. AWS CloudWatch. It's a monitoring, observability service, blah, 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 blah. You can read a little bit more about it. This, I'm going to be putting it here. So my API gateway will be exposing access logs and error logs and stuff like that. And I also want to have a separate log group for my Lambda function where the processing is happening. I want to have also my logs here. So this starts to be complete, right? I have a complete application that have an API gateway to be called publicly, have processing happening in the Lambda reader, data is stored here. So we quickly built a 3-tier web application. Of course, I can add something like CDN in front. I can add more security in the front, but let's keep it like this for now. Now, how about writing? Let's say I'm building a small part of an e-commerce application, and we need to add products to our table, and then we need to read products from this table, right? All this is bothering me. This is not as clean as it should be. You know, we need to let our design breathe. It's actually a bummer that they don't teach us art in engineering school, or not art, but like just how to make things look clean. And
eternity later.
All right, let's go to the right app. So now let's say another domain in the application, another team, they emit an event whenever a product is created. You know, whenever maybe it's the warehousing team and they emit an event whenever they receive a new product is added to the shelves in the warehouse. And so what do is they send us this event in a queue, right? So we subscribe to their queue. And let's go to SQS and put it here. It's not part of our domain per se, but it's something that we interact with. And so this SQS is where we receive messages. So we want to consume the events coming from this queue and then do some operations on them, right? We get this product, then we need to call, for example, the pricing domain to get the price of this product. And then we need probably to call the, I don't know, studio domain to get pictures of this product. And then we need to call different types of domains to get different type of data that we can combine, and then we store into our own database that we can consume going forward, rather than having to call all these domains when we get a request to show the page. The usual way of doing this is when you get a request from the front end, then you send that request to your database and you start doing 10 joins, join with the pricing, join with the description, join with the warehouse, and combine all those and then send them back to the front end. This operation is quite costly. Your users are waiting for you to do all these joins. So the opposite, what you can do is you can do this writing, this data cleansing and this data preparation beforehand. So when your users go to the page and try to load the page, the information is already ready for them, right? So expensive write, cheap reads, rather than the traditional way, which is expensive reads but cheap writes. When we want to write, we just put everything into their own table and normalize, and then we forget about it. So for websites that are heavy on the read aspect, you want to do it this way. Thank you all for watching. Step 2 is coming tomorrow, where we will be designing the writing layer using AWS step functions. So make sure to subscribe for that so you don't miss it. Also, I will be adding it just here when it's up, so all you do is just click on the banner. Until then, talk to you soon. Peace out.